All right, hello BC. It's Friday night. Obviously, everyone who's anyone is recording a screencast right now for their BC Calc class. So I wanted to, when I thought about it, and I wanted to assign some homework with our volumes of revolution, volumes of solids of revolution, I should say. But I realized we didn't get quite as far as I wanted to in class today. So I want to talk about how we can draw some, and then how we can set up these integrals, and we'll have a lightish night of homework, similar to what the YAM sections have had. So I want to think about this curve, y equals the square root of x minus 3, from 3 to 7. Now I want to revolve it around the x-axis, just like we did today. And today and tonight and this weekend, we're only going to be revolving around the x-axis. I think my AB friends know that revolving around the y-axis is coming. And TIC friends, you could probably sense that too if you thought about this. So let's first sketch this curve, right? So let's just root x with a shift to the right of 3. Right? So it's going to look something like this. It doesn't need to be beautiful, but it comes out here, right? But we're really only concerned with out here to maybe 7. Okay, so let's talk about this. This curve in 2 space. I'm going to try using this highlighter. Very fancy. We're going to try with this light gray first, but maybe we'll progress and use different ink colors later. We're going to be revolving this area here. This area, not just the curve, right? We're going to be revolving this area around the x-axis with my little red arrow over there. Okay, and when we revolve this around the x-axis, as we said today, right, we're going to get this interesting looking 3-dimensional shape with these cross sections that we can actually talk about. Okay, so when I revolve this around the x-axis, right, at each point, right, if we think about what this curve is going to do, each point, just like we said earlier, we're going to generate these sort of discs or wheels, right? Wheels, I say that because they're going to be oriented sort of vertically around the x-axis. And we can sort of think about what that would look like. And at this point here, we draw a line up to the curve, right? That's sort of my radius of my disc. And then I would have some more, a slightly bigger radii, out to 7 here, where I have my biggest radius, right? Here we have our biggest radius. Now this is a very ugly picture. Hopefully we have some artists in the room that can really show me up here. But if we can sort of sketch this, sketch what this curve would look like, right? Sort of a dotted line that goes through the back of these guys, right? We can see, this shouldn't come down, it should just go up, right? We can see, I'm probably going to erase something I don't mean to. Oops, there goes my arrow. Right? We can see this sort of cup facing outside that we would be building here. And I'm actually going to shade in this outermost disc to illustrate how solid this thing is. So maybe we can draw this. Maybe I'll bring colored pencils like our friends in the YAM class had this week. But we can see that we're going to have these vertically oriented discs that look like this. And we want to add up the sum of all of them, the sum of the areas of all of them, right? Because we know that the sum of all of my disk areas, which is infinite, right? That sum has to equal the volume of my solid of revolution, right? And this is what we saw today when we revolved that cone, when we revolved the straight line, y equals 2/3 x or whatever we picked, around the x-axis. We saw that, right? So let's think about how we would do this, right? These cross sections perpendicular to the x-axis are circles or discs, right? If they're infinitely small or thin, right, they have sort of no thickness, or that dx thickness that we've talked about, right? They're really circles. So if we think about the area of one disk, right? We know, like what we said today, that's just pi r squared. And now what is r, right? R is, for any disk, we'll pick the middle one, this, right? This r, the height of my function, right? This function has some point x comma y, and r is this y, right? It's the height of the function. This is really, again, x comma root x minus 3. That is the height of my function. So the area of one disk is really pi r squared, which we know is pi times root x minus 3 squared. I'm going to leave it like that. Obviously, that's just pi times x minus 3, but I'm going to leave it like that just for a tiny bit. Okay, so if we want to add up the sum of all disk areas, this thing right here, the sum of all disk areas, well, that's just going to be a definite integral, right? And we want to add the sum of all disk areas. And now we need to think about whether we want dx or dy here. And because these are stacked sort of along the x-axis, they're stacked along the x-axis, and our interval is moving along the x-axis, right? We clearly see our bounds are going to be from 3 to 7, right? We know we need dx out here, right? We know we need dx out here. So this thing says, right, that I have a infinite sum, right? Because I have infinitely many of these things from 3 to 7. And then what do I want in here? I need the area of my disk. I need my pi r squared. My pi r squared, which is pi times the square root of x minus 3 squared. So again, right, this thing here says infinite sum, and this thing says of our areas of disks, right? My areas of my disks. So we have an infinite sum of the areas of our disks. We can take a pi out here, and we can get from 3 to 7 of x minus 3 dx, which is kind of a weird thing, right? You'd think this thing would be way trickier, but it is not, right? It is not. So we can follow this through here to find my infinite area, or you guys could do that on your own if you want to pause me first, right? But this isn't a particularly hard integral, right? Where I have pi times x squared over 2 minus 3x, quick save with that x squared over 2, evaluated at x equals 3 and 7. So this is actually going to be, a fairly messy number, right? It's going to be pi times 49 over 2 minus 21, and then minus the quantity 9 over 2 minus 9. Whatever that is, who cares? That's just some number. It's going to be positive. You can guess, maybe, before you even evaluate that, what you think the area of this, I don't know what that looks like. I don't know. Maybe you guys can decide what that shape looks like. Maybe like the front of an airplane or something. I don't know. My mind's on vehicles because of my son. So we're going to get something. We have this expression, right? Because we have these infinitely many cross sections perpendicular to the x-axis that are these circles or disks, right? We can say disks have very, very small thickness, or circles because they have no thickness. Okay, so for your homework this weekend, I'd like us to think about 2 more of these problems I'd like us to do from front to back. Okay, the first one I'll help you sketch, and then I'll help you start sketching. I don't want to, do too much here. We'll talk about y equals 1/2 x squared from 0 to 4, we'll say. From 0 to 4. So what does that look like, right? That's just a parabola from 0 to 4. It's going to look something like this. It's going to open kind of slowly. Oops. Bad. Kind of slowly. It doesn't really matter, right? Maybe here's 4 out here. And then, you could find this might be 8. And we're going to revolve this area here around the x-axis. Take that area from 0 to 4, go around the x-axis. Okay, I want you to try to sketch it, and I want you to think about what that thing will sort of look like when you revolve it around the x-axis. Okay, so we're revolving this area around the x-axis. So let's sketch with disk cross sections. That's sort of the first part. Let's write an integral expression. And let's evaluate it. Let's evaluate it. Okay, maybe you can guess. Maybe you can ask yourself, is that going to be more or less than this one up here? Who knows? Maybe you can play with that. Okay, so that's the first problem, and then I would like you to do it again with the with the area bounded by, and this is sort of practice from our last review. Let's do the area between this, and this. Oh, look, ln back in our lives after our quiz. So these guys, I'm not going to sketch this one for you, form a they enclose an area, okay? And so do these same three things: sketch with disk cross sections, write an integral expression, and evaluate it for this guy revolved around the x-axis, right? So you're going to take these two areas and revolve them around the x-axis, just like we did in our example up there with root x minus 3, okay? So sketch with the cross sections, kind of like I did with that blue. The more I come back to it, if we zoom in, this drawing kind of stinks, but if you zoom out, it looks kind of okay. I don't know, you're probably all nauseated from that now, but and then let's write an integral expression and evaluate it. Maybe we'll have colored pencils, and maybe we'll be at the board trying to make pretty pictures on Tuesday. So have a good weekend, and email me if you have questions or if this wasn't clear.